Are you able to see my screen?
Yes, sir, it's visible.
You are able to see the PPT, correct?
Correct. Yeah, it's visible, sir.
Oh, okay, so we will start here. Game present screen. Okay, so good evening, all of you. So thanks for coming to this session, taking time and coming for this session. So here I am Aditya. So I am going to speak on the subject of autonomous driving and artificial intelligence. So our today's agenda is like this. I'll try to speak about what is machines, mechanics, and software in very first, and then we'll try to understand the traditional way of thinking of software and what is the new way of thinking of like AI way of thinking about the software, and then we'll try to understand the autonomous driving, what exactly is it, and what is the status currently we are in the with respect to the industrial standards or the market, and then I'll try to discuss a little bit more on how is AI is helping in achieving the goals of autonomous driving. Yeah. So if you have got any queries or doubts, you can interrupt me at any point, and then we can have the discussion. All right. So now let's try to understand what is mechanics. Okay. So what is mechanics? Mechanics is basically a branch of science, okay, physics, which studies the motion and behavior of physical objects under the influence of forces. Okay, so the whole idea is like now it's about the forces one is trying to understand. It's all about the physical objects which are present. Okay, so the movements of these forces and the connected behavior is something which comes as part of the mechanics. All right. So when these mechanical objects comes together, then what exactly it forms is basically a machine. So what is basically a machine? A machine is a device or a tool which is used to perform a specific task. It could be lifting a water from a well, it's like a pulley or something like that, or it could be a simple screwdriver is also a machine, or it could be any powered, like in the sense like it could be electrically powered or fuel powered or human powered or animal powered. So the image what you see here is nothing but a turbine which runs on with forced water. All right, so this was a machine which was there. All right, so now like traditionally how was these systems were there? So traditionally when the electricity wasn't there, the machines were something which were running on either water, steam or coal powered. Okay, so like back in 18th century or 19th century, before 18th century, it was the water powered machines which were running, and they were called the water mills. All right, so for any of kind of a work, you know, it's the water mills or the force of the water was being used. All right, with advent of the steam engines in 18th and 19th centuries, the movement has become from the water to the steam. So how were they trying to produce the steam? They were trying to heat it using either coal or something, and then the steam is produced, and this steam was being used to run your or produce your circular motion. Okay, the rotational motion could be used for so many different ways. All right, so these are the machines, and then that is how the steam engines and locomotives and mobility has come into picture. All right, so now when machines can solve all your problems, then what is the need for the software? So now, like, why do we need a software? So the software is something which comes at the advent of like where we need highest precision. So where they need the highest precision, you know. So like and also like well, let's try to consider a situation like this in a fuel injection equipment. All right. So what is a fuel injection equipment in a diesel system? The heart of the system is nothing but is the fuel injection equipment. It is the rail and also the injectors altogether. All right. So whenever one injection happens, all right. So the pressure in the rail rod basically falls from 2000 atm to 1500 atm. Okay. So like whenever this actually happens, the fuel is supposed to be pumped in. Okay, the rate at which this is supposed to happen is almost at what is it, kind of 200 milliseconds, which is not really achievable by an mechanically operated machine. Okay, so in a mechanically operated machine, so the whole idea is like mechanical arrangements, and to achieve such kind of precision we need to have like very meticulously the hardware is supposed to the gear wheels or everything are supposed to be made, and that is not something which is achievable at some points. So it basically meets a dead end at some point. Okay, at this point the software actually comes into the help. Okay, so what exactly is the software? So the software is like you also try to understand the paradigm shift what was happening as the history is being told. So the initially it was about the hardware and mechanical or gears or something like that, and then the logical capacity or the decision making capacity, this is something which we started or we are trying to push into your microcontroller. All right, so this is basically the logical capacity. So this is a new paradigm shift of achieving your work done. The software itself cannot actually do everything, but this is the intelligence which is basically like what is it, controlling the actuators. All right, so this is how the software has come in. So like what are the primary advantages of having software? It's flexible and adaptable. So like the hardware issues were removed out. All right, and then it is quick and cheap. The hardware need not be made. It's just about like making quickly a couple of lines of code, and then it's more reliable and consistent. If the hardware gets deformed or the wear and tear over the period of time or something like that, so that could always create a problems. But the software isn't like that. And then the precision, as I have already mentioned, these are the challenges. What software code is nothing but it is set of instructions which are laid out for your hardware to do a specific task. Okay, so it could be an simple washing machine controller or like a fridge controller or an automobile controller or anything. Okay, so I have also mentioned that like physical to logical. So now from physical we are trying to convert that into logical. Okay, so now the intelligence is being captured onto your controller. Initially, to achieve any work, it was the physical arrangements, like let's say like the water mill itself. The water mill itself, you have some certain kind of fins, like in our previous image. It is a kind of fins, and then the injector. This is something which is it's kind of a mechanical arrangement. There is nothing called logical design there. All right. So now the flow of water is something which sets everything is in motion, and the force is being captured by the turbine, and that is being used. Okay. But in case of software, you are basically trying to make the decisions, true or false, and all this logicalness. So this logical thinking capacity or intellectual capacity is being housed under the controller, which basically helps for us. Okay, so and then like what is facilitated in this? The electronics, the advent of the electronics is facilitated in this. So the initial days of electronics was like this all what you say, kind of the metallic switches, the relays, and vacuum. The semiconductors, and then like also the vacuum chambers. These are some things which were being used. Okay, the like generation 1 transistors were like this, and with the advent of like the transistors, FETs and MOSFETs, which you can house it under a very small microchip, the things have become much more easier, right? So now like these transistors, FETs and capacitors are actually enabling us to achieve the same thing. Yeah, so now like you can actually have such a powerful code on like something like simplify like a mobile phone too. Yeah, so that is what software is. So now like if a piece of the software is basically developed for a specific purpose, then it is basically called embedded software. all right, and the software which is being developed not for an specific purpose, which is being developed for a kind of a generic purpose, is basically called a generic software. Okay, so the computing devices are something which also revolutionized. Okay, so like we will again come back to this computing devices at a later point, where in which like the AI was there since 1980s, but it wasn't so famous till 2005 or later parts of 2005. The reason was the computing capacity. Okay, so the computing capacity was very bad, like in the sense like not bad, maybe it's not very sufficient enough to basically what you say, facilitate something like neural networks to run, or to do the backward propagation and then try to make the decisions out or something like that. So that was the what you say, kind of lacking. So like in back in 2005 or 2007, it was Pentium processors were being used. Pentium 4 was the most popular processor at in 2007, because I bought my system then, I knew about it. So that was the processor. It wasn't even a dual core. But the current day processors, whatever we buy, are basically coming with like more than 6 cores or 7 cores with them. All right. So this is basically facilitating us to basically do this neural network training, or like machine learning or such kind of stuff. Okay, so now again the embedded systems are like again the application specific purpose. It could be a microwave, washing machine, fire alarm, or anything, but in our case it's more about the automobile. Okay, so it is like automotive embedded software development, right? So now like so what is an automobile? Okay, so what is an automobile? Automobile is like any moving car which is used for transporting. It could be a bullock cart, bike, car, or anything. It's basically an automobile. Then why do we need software in automobile? As I have already discussed about one instance where we are supposed to maintain brake pressure, which is about like 1500 atm, which is supposed to be maintained at 2000 atm, and then after every injection this drops to almost in the range of 1500 to 1815 atm. Okay, so again the injection motor, whatever is present, which pushes or like pumps the fuel into your rail rod, is supposed to push, or like which is supposed to pump the fuel into the rail rod at such rate, at a rate of like 200 milliseconds, right? So now in automotive field, each of the features whatever you implement are expected to run at 10 milliseconds. Okay, the task scheduler is scheduled at 10 milliseconds. So now this is highest precision, so like to achieve that, the mechanical parts aren't possible. Okay, that it cannot be achieved. So the only way that you can achieve is using your microcontrollers. All right, so why do we need to maintain such kind of a high pressure in your rail rod? That basically creates atomization, and because of which you'll burn the fuel better, and then you'll basically you burn the fuel better, and basically reduces the emissions. Okay, and emission norms could be achieved. All right, and this is one need for software in automobiles. Not just that, the ADAS applications, the advanced driver assistance applications, like the autonomous driving, the parking assistance, or the lane departure system, or what you say, even this brake assistance systems, and all these things to be acting like very precisely and perfectly, we need the software. And also for diagnostic control, and also like the flashing over the air, and for all these things again. So these are all different things. And like offline, this is becoming a popular, which is only on what you say, kind of researcher table, which is not yet rolled out into the commercial market, is something people like the OEMs are thinking about car OS. So like then something to be understood more like an Android operating system. Like we have the Android system, right, where in which we are basically installing the applications of our choice. So maybe in future at some point we are going to have something like a car OS, and whatever features that you want, maybe you could download and enable them. Okay, that may need some kind of hardware fitment too, but if the hardware fitment is there, you can always download. Maybe such kind of situation could arrive at some point, but this is something which is being kind of like in incubation, where things are being thought about. So the prior to this was the flash over air kind of an application. So all these things again you can understand, these are some things which are being achieved only by having software in your car, not just the hardware. The hardware was so the hardware was simply the hardware. It is just achieving your mobility and then the traction only. But the software is something which is allowing us to achieve the finer aspects of whatever features that we are experiencing today. Okay. So now, like, how is AI different from the traditional programming? Because the traditional programming was there for so long, then why exactly are we moving from now, or like why are we trying to house this new paradigm of AI into your the microcontrollers? So that is because the traditional programming is something which is created on rule-based system. So like it's more like this: at the end of your road, you always have left or right to take. Okay, so it's the decisions are something which are like premeditated, and then they are something like which are captured on your controller. Okay, so they are premeditated, so it is basically requirement driven. So there are requirements, and then the algorithm is something which has been created and which produces the desired results, because it's a premeditated. All right, and now the results whatever are being produced in the traditional way of programming are very certain. Okay, so when you provide an input, it is basically the output is 100% sure it's going to happen in a specific way, so that happens. And what is the outcome of this? It is basically an algorithm or a program in a specific language. It could be embedded C, and of late embedded C++ is becoming famous. Or like if you are trying to use something like an IoT devices or something, devices like Raspberry Pi or something like that, then you end up using something like the Python language or something. Or you could also go for something like RTOS or something like that. So like some kind of a program which is sitting on your controller, which is enabling this. Okay, and then instructions are programmatically laid out. So like whatever rules that you have received as requirements are basically programmatically presented there. Okay, so now programmatically it simply means that is that which is understandable by a machine, like the hex code. Okay, because a microcontroller or a simple computing device can understand only zeros and ones. It doesn't understand anything which is in higher, right? So that is why we have this assembler, compiler, and all that stuff. Yes. So and you can see the traditional programming basically takes the data and then the program, and that is the output. Okay, so but now what is AI programming? So AI programming is again one more step ahead. So what exactly does that mean? So first we started with mechanics. Okay, the physical objects, when they come together they will basically become the machines. Okay, but machines has got a limitation of not able to achieve the finest time, or like the precision and maintenance cost, and all these things were the overhead when we are using only the machines. Then came the software. So the software also has some limitation. So what is the limitation? So now a premeditated program, whatever is present, it cannot solve the problems which cannot be like formulated into requirements. Let's say like a simple example could be a face detection algorithm. In a face detection algorithm, it is not really possible for you to premeditate it and then write it down. Some amount of algorithms can be done, some image processing algorithms, but the face recognition or face detection, these kinds of stuff are something not which cannot be premeditated, or the formulations of such kind of data for such kind of problem statements. The requirement formulation is really very difficult, and then implementing that would be really great challenge, and the code is also very humongous. Okay, so these are some what to say kind of again the dead blocks for your software to go forward, or like the traditional way of software to go forward. And this is the point where actually the AI comes in. So what exactly is an AI? AI doesn't start with requirement formulation. Rather, it starts with something called data set. So what is a data set? So data set is nothing but, like in human terms to understand, it is an experience. Let's say you are basically like there is a famous example of a Ford car liking the strawberry ice cream. So this was a very famous case. So like at some point, like a customer has bought this car, a new model of a car, and then they had a like, tradition of buying this, getting ice cream to their dinner at every day. All right. So whenever he has observed one kind of an feature, like one kind of an observation, what he made. So whenever he has ordered a strawberry ice cream, okay, so the car wasn't starting quickly, all right. But when he tried to order some other kind of an ice cream, the car was starting quickly. Okay, so this is something which he has reported to the engineer. So like they have come down to understand what exactly was happening. Okay, so like they tried to travel along with him and try to understand what exactly was happening. So whenever he has ordered an ice cream which is other than a strawberry, which wasn't a very famous ice creams. So he was trying to go to the behind or pick it from the behind and then get it. So there was some lapse of time. But when he was asking the specific the strawberry kind of an ice cream, it was just in the front of the shop, and then the delivery was much faster. Okay, so in the meantime, what exactly was happening? The airlocks were actually getting activated, okay, because of which the car wasn't starting quickly, rather something else was happening. So now try to understand. So this is no logic, this is only out of experience one can understand about this. Okay, so like there is also a famous data science case where in a storefront, when the nappies and the beer which are placed next to each other, the sales were really very great. Okay, this is also something, again, no logic. How, why exactly the nappies and beers going together very great? Or it's in Indian terms, maybe we can understand the chicken masala and chicken, maybe they will go together when they are kept next to each other. So the idea is like it is basically the association principles. These are like no logic. This is something which is an experience from the given data samples, what they have been observed. So this is something which AI is all about. So like we have tried to put machines together to get our work done. So we hit a deadlock where the precision was a problem, or maintenance or the cost was a problem. Then we try to use the software to solve our problems, and then we have again hit a deadlock where if there are problem statements which cannot be formulated into requirements, so that is a deadlock. And now we are moving again a step ahead. Now we are trying to house the experience into the controllers. Okay, so what is this experiencing, housing the experience into the controllers? So again, so the idea is like from the given data set, it is an observation. So it is the statistical and observation. Okay, so it's basically statistically the models are being created and they are housed into your controllers. Okay, so the input for an AI algorithm, AI programming, is basically a data set, and the process is basically not programming, rather it is training. Okay, so we basically train, and once after we train, what exactly we get is nothing but the ML program. Okay, the ML model, right? So it basically gives you the model, which is nothing but a bunch of numbers. Okay, and then here the results are probable. In experience, again, you can always tell you are only probable, you are not pretty sure, it could happen. Okay, so the AI program, the outcome is not certain, rather it is probable and predicted. So the word prediction and probable, they come together. The reason is because it is not certain, it is not computed. So like for a traditional way of programming, if you ask like what is 2 plus 2, the answer is expected to be 4, and if it gives you like 3.999 or like 4.001, both are unacceptable. Okay, but in the case of AI programming, if you try to do the same addition operation, 2 plus 2, if the solution is about like 3.9 or 4.1, basing on the order of error what is acceptable by your client, it is absolutely all right. The range of answer could be like anything. Okay, so that is something predicted probably. and then the outcome is basically math and then the algorithm. Okay, so like in an AI program, the input is basically the data and the output is nothing but your label. It's more like a supervised way of learning. So in a supervised learning, so the data and output and the outcome is basically a program. Okay, so this is an hypothetical function, a new function what you are creating. Here you have to pay attention. From the requirements, they have formulated a program, and then the outcome is an output. Okay, so an AI algorithm is nothing but a bunch of numbers, and then output is a function. Okay, so the idea is like, now how does this ES to a car work? So there are four mics which are fitted to the four corners of your car, like the light clusters. Okay, and then these are receiving the sounds from the outside, and these sounds are converted using a USB controller inside. So they are being converted into something called wave coefficients. So now the sound, which was like the audible thing, is being converted into numbers. So now that you have numbers, you know how to label them. So this labeled data is being trained to produce something called this AI algorithm, the sound algorithm. So now the car was able to classify about 21 different kinds of sounds. So the sounds from an ambulance, sounds from a police, sounds from like a crying child, anyone who is shouting outside the car, or like the train sound, the bell sound, and all these things. So totally 21 different sounds we were able to classify. But our customer's requirement or request was to achieve a precision of 10 to the power of minus 5. It simply means because it is like for a brand, for a car, it's basically brand. Okay, so it is trust critical and also safety critical thing, right? So for this reason, the expectations of the clients is about 10 to the power of minus 5. What exactly does that mean? For every 10,000 samples, what they have provided, he expects only one sample to go wrong. Okay, because we have also tried to understand in AI the AI way of programming, the output is basically predicted and probable. So now he wants to speak about the precision, what is the precision which is supposed to be achieved. So what is the precision he is expecting? It's basically 10 to the power of minus 5. So like for every 10,000 samples, he wants only one sample to go wrong, not more than that. So we were able to implement it like at 85% of accuracy, and still it is being worked. Okay, so that is ES to a car. And similarly, an innovation project was again came up to provide a nose to a car. So the idea is like, if the car smells bad, it is expected to basically either alert or something like that. So it's expected to alert, or to it basically to actually create this AC vents to open, or expect the air from the outside to flow in, or something like that. This kind of decisions will be taken by the car by itself, just by giving nose to a car. So this was the sensors which we were trying to train up again. So this is again not this is difficult for anyone to actually formulate requirements for this. So for this, a sensors were fit, and then this data is being extracted out, and this data is being again compiled all together to achieve this. So these are all some things which are actually on the researchers bench, which are being implemented. Okay, and back in 2018, I have seen like a RNN, recurrent neural network, was being used for like what do you say, to achieve emission norms, the fuel parameters like the VGT, EGR, and all these parameters, all control valves, and all these things were being fed back again into the recurrent neural network. So at some point, the expectation is that the neural network will learn without being explicitly softwarely coded to how to control these valves and everything, so that emission norms can be achieved. So this is something which was being done in 2018, and but the new way of doing is like, now the fuel injection systems are going away, and then the battery management systems are coming into picture. So here again, we are basically working out the smart way of charging, and like the smart way of basically switching the networks. So the idea of formulating requirements for something and implementing a code is basically slowly being ruled out in the market. And something which is coming into the whole of the picture is like already we have the data, already we have the actuators and also the sensors. So we simply want to throw in a controller which becomes intelligent by itself over the period of time, which is something like a recurrent neural network. Or else like already you have the data, you train it on your bench and dump it onto your controller, so that it is like a one-time dump and then it starts to work in a specific way. But the idea is like you are trying to port the experience into the controllers. So this is the new way. So like from the physical to the software, which is logical capacity, and from logical to experience is something the new capacity what we are pushing. All right. So that is something which is happening. And other than this, the vehicle detection, pedestrian detection, the lane detection, and then the automatic license plate detections, and the what do you say, the smart the navigation systems are the new things which are being meditated, like again are on the research benches where which we are working on. So the idea is like, let's say you have got an 50 kilometers or like 500 kilometers of ride, and then you have got X amount of fuel, and your driving pattern doesn't help you reach if you do not fill your petrol to your destination. In that case, it basically chooses a navigation pattern, and not just that, it will also tell you about like at what speed you are expected to go. Okay, these are all some things which the neural network which is present on your car will start to learn from your driving patterns and also suggest you what is best for you. Or else like it's simply trying to tell you how exactly can, as long as it is only advising, it is basically either level 3 or level 4. But when this is going to become hands-free, so these will be the algorithms which will automatically happen in a car, and without the intervention of the user or without the user knowing about it, the car will be fully autonomous and it will take care of itself, and it basically does our job much more smoother. Okay, so these are few things which I wanted to share. So I'm open for queries. Any questions? Yes. Any questions, queries, or any comments? Anything which is unclear or something like that you wanted to know from anything else? Even you can ask me anything more in detail about these projects also. I can try to give you much more lengthier descriptions about this.
Hello, sir. Good evening.
Yes. Yeah, please go ahead.
Okay.
For the instance, we need to learn artificial what is called neural networks. Is it one part neural networks?
I did not get your question. So you are asking what is neural network? Is it?
No. The AI for AI neural network is the one part, right?
Yes, exactly. You are right. So now, like, see, in AI we have totally 4 different terms again. So which falls under one umbrella: the data science, the AI, the ML, and then the deep neural networks. Okay, the data science is something which is dealing with handling the data only, the data munching, data cleaning, data extraction, and all that stuff. Okay, the machine learning is something which is dealing about like statistical understanding of this data and experiencing and all these things. And the deep neural networks, or like the multi-layer perceptron or AN, and all these things basically fall under this deep neural networks or neural networks. Okay, the term deep is because the experiences are being what is it, kind of layered. Okay, so it's this is something which is being inspired from the human brain behavior, or like we are trying to mimic. It is not that we have already mimicked, we have achieved something. because a human brain contains a billion of neurons which are interconnected and they work in a specific way. So they have took the inspiration from there, and then they have programmatically created something called a neuron, and sometimes they also call it perceptron, and then several layers of these neurons are placed to achieve the same thing. Okay, so this is a subset of machine learning, and the AI and deep neural networks, these things fall under an umbrella term called artificial intelligence. So what is all artificial intelligence? Anything where in which you imply your statistical capacity to understand the problem statement and solve the problem. That is basically called AI. Okay, the ML algorithms are something like simple linear regression, polynomial regression, logistic regression for like the kind of classification problems, SVM, k-mean clustering, and all these things are like something which falls under ML. And from the point where you speak about perceptron or like neuron or neural network, that is where you fall into the realm or like under the new term called the neural networks. Okay, so if it is like if it is trying to learn over the period of time from by having its own what is say feedback, then it is called recurrent neural network, or else it is kind of a neural network. So there are again many families under neural network, like the CNN's convolution neural network, or like VGG, and quite a few. Yeah.
Regarding this AI artificial intelligence, regarding island, is there any examples, sir? So how can this AI in island? I was island natural gas industry. Is it this is applicable, sir? You had any examples? In this
I could tell you like this is an and just it's an orthogonal in the sense like you name the field, you can find at least one place where AI can be pushed in. Okay, so like I personally haven't worked on this kind of fronts. I am basically working in automobile sector only. Where exactly can this be used? It's about the use case where you can use it. Okay, I'll tell about one of my friend who has took a course in this AML and then tried to use it at his industry. What exactly did he do? So he had got several machines at his place. Okay, so which had got this what you say date of installation and date of maintenance and all these things. What exactly did he do? He simply tried to go around and take the snaps everywhere of these machines. Okay, then when he came back, he has applied the OCR mechanism, the optical character recognition, which uses again a kind of a deep neural network, which extracts basically the text from the images and then populates. He tried to use that data to populate it on an Excel sheet and then try to create the alerts automatically which machine is expected to be maintained at what time. Okay, so it is like I would say it's a domain independent thing, the AI. All right, so it's all about like what is your purpose. It is about like you know that you can recognize the alphabets and everything. We have OCR, so he has simply tried to build up such kind of an application. It is applicable in any industry, and he tried to use it there. Okay, in oil and gas industry, whatever you are speaking, maybe you can speak about a problem statement and just try to think in this way. You are trying to house be it embedded system or like a non-embedded system, simply like on a generic controller also. The whole idea is like you are what you say concocting your experience together and then trying to solve your problem. Okay, it could be maybe some OCR thing, or like maybe trying to control the wall or something like that. So some such applications could be drawn. So maybe it could be a computer vision based, or like simply maybe a intelligent chatbot or something like that. The IRCTC, whatever you see, or like the HDFC EVA, and all these things are basically the AI applications. Okay, from so many conversations what we have made, so the AI is basically trying to what you say filter and infer. So whenever someone says hi, what to respond with. Okay, how many of you have tried Chat GPT, or how many of you have heard about Chat GPT?
Yes, sir.
Yes, sir. We all have heard about
You all have heard. Yes, that's great. So now Chat GPT is nothing but an It's a huge, humongous language model. Okay, whenever you type in a question, how does a Google answer? Google basically works with a page ranking algorithm. In the sense, like anyone who is hitting more number of times a specific page, that is the first page which appears. Okay, but unlike that, ChatGPT is a bit more intelligent. What exactly is it trying to do? When you try to ask a question, it is basically trying to pick all these pages, extract the content from the pages, and whatever it thinks which is relevant to your question, it is fetching that data, formulating it into a passage, and then trying to provide it. Okay, so this is something which is happening. So try to understand, try to understand the paradigm which is happening. It is the experience which is being achieved. Okay, so getting the data was previous. Now it is not about getting the data. Let's say I want a specific application or something, so that we can achieve basically like that.
Hello, sir. Good evening. I have a doubt regarding the implementation of this. Thanks for the session and thanks for the clarification about the interconnection between AI, DL, MN, and the other parts of artificial intelligence. But still, in academic point of view, for example, for the basic learning about this technology, to learn about the algorithms, what kind of sources which you will suggest for the students?
First of all, like I would tell you in two different ways. So, from academical point of view, always a subject to be understood. It is to be understood in two different ways. One, the applied, and also the theoretical. Okay, so anyone who wants to understand the theoretical one is someone who is going towards the research kind of stuff. These people are someone who are expected to study and learn about the mathematics, statistics, and behind stuff. Okay, and the second part is about the applied. So already there are so many of the algorithms which are already in the market. Okay, deep linear regression or something like that, the multinomial, polynomial regression, and all these things which are available. And these things are already present on your the what do you say the pre-trained library, libraries which are provided in languages like Python. Okay, the SQL library. So basing on the student's interest, what is the field of interest? It is he wants to develop the algorithms or to use the algorithms and solve the real-time world problems. He could basically choose one of these fields and he can try to progress in that direction. Okay, so and in terms of job market, I will try to answer this question. The application things are something which are very fast. You will get picked up, or like you will be picked up much faster. And the other one, algorithm development, is purely for R&D. So that is how I can answer this question. Does that answer your question?
Hello.
Yes, please.
Yeah, hi, good evening, everyone. I hope you all like the question. So, talking about the code, as you all already know, that we are starting doing our data science program by our course trainer, Aditya sir. So, talking about the course, it's a 9-month course where you all will be getting weekend live classes, and you all will be also be provided with placement assistance, mentorship, and mock interviews. In this, you guys will be learning about Python for data science, probability and statistics, data acquisition and unstructured data, applied data science, deep learning about data science, tabular, and some machine learning. In this, the tools which you guys will be learning about are Power BI, Keras, NumPy, Python, Excel, and so on and so forth. Talking about the course, you all will be learning some course including some major as well as some specialization course in this. In this, you all will be learning some common things such as introduction to Python programming, intermediate programming, Python for data science and machine learning, probability and statistics, maths refresher for data science and machine learning. This will be common for everyone. And after this, we are having 4 to 5 specialization in this. Then it's up to you which specialization you want to go for. The specialization consists of data acquisition and unstructured data, applied data science. It's a specialization one. The other specialization is data visualization with Tabula, product strategy business, tools for data analysis. The third specialization includes machine learning, unsupervised learning, recommender system, predictive modeling, and time series forecasting. The last specialization consists of essential math for machine learning, supervised learning, unsupervised learning, recommender system, predictive modeling, and time series forecasting, and deep learning. These will be the specialization for you guys. If talking about the course fee structure, there are 3 different type of fee structure which we have differentiated. In this, you will be learning from basic to advanced. So we have 3 different type of course in this. One is for beginner, which is of 9 months, and in this the fee will be rupees 2L, that is 2 lakh. And in this you will be learning about introduction to Python programming, intermediate programming, Python for data science and machine learning, probability and statistics, math refresher for data science and machine learning, specializations and projects. The other one is for intermediate and it's for 7 months, and the cost of this is 1.50L, that is 1.50 lakh. In this you will be learning about hello.
Yeah, you're audible.
Okay. So, as I was talking about the intermediate course, it's a 7 month course. In this, you will be learning about probability and statistics, math refresher for data science and machine learning, specializations and projects. This costs around 1.50L, that is 1.50 lakh. The third course is for advanced level course. In this, you will be learning only about specialization and projects. This costs around 1.20L, that means 1.20 lakh. This is about the course, and if talking about the growth in this course, you can see 28% annual growth in your job, and the average salary package of this is 4.5 to 22L. And if talking about the salary which any learner has gotten from our side, it's 6.9 LPA is the average CTC which some learners have gotten from our side, and 30 LPA was the highest CTC. Talking about some certificate which you will be getting from this course are NSDC, which is National School Development Corporation, and it's a government organization, and this particular certificate is globally valid, which means you can use this certificate all around the world. The other certificate is from our side, that is ISIEINDIA, and that's all for this course.
So thank you so much, Megha. So if you guys are interested in the courses, so you can fill the form which is available in the chat box. Over to you, Aditya sir. Kindly take the query session.
Yes. So I'm again open for any queries. So
If anyone is interested, you can fill the form which is available in the chat box.
So I think Aditya sir, we are over with the session.
okay.
Yeah. So if anyone has any question, you can ask it right now, or else we will wind up the session. Yeah. So thank you, Aditya sir. Thank you for the session. Thank you for the lovely session. It was really insightful.